Today we're going to look at how to interpret graphs of functions. Now there's many new vocabulary words that we will be using in this lesson, including extrema and end behavior and relative maximum and relative minimum. And we'll also be looking at words that you may already know what they mean, such as positive or negative, increasing or decreasing, line symmetry, as well as intercepts. So we'll be looking at a graph, and describing it as best as we can using as many words as we can out of these new vocab words. So we're going to start with this example. Now, the first question that we should ask ourselves, is this a straight line or not a straight line? Now, it may look a teeny bit curved, but that's actually just my hand drawing the line, so it's a little bit curved looking, but it is actually a straight line. You can see it drawn in the textbook. It's on page 56, but it's a straight line, so we would say that it's linear. Then we want to look at the intercepts. The intercepts are where either the x-axis is crossed, which is the x-intercept, or the y-axis is crossed, which is the y-intercept. So in this particular case, the x-intercept would be right here, and the y-intercept would be right here. So these values would be x equals 1 and y equals -5. If we want to be more specific and interpret them and describe what they mean, we would need to look at how the graph is labeled. So you have time is your x-axis, right here, and temperature is your y-axis right there. So time, the more time that goes by, it looks like the temperature is rising because this graph is representing controlled thaw of sample, which basically means that they are thawing something out from the freezer. So the more time that goes by, the higher the temperature is. So if we want to talk about what x equals 1 means, where x equals that's the intercept for x, we would say that it means after 1 hour, our temperature is now up to 0 degrees. If we think of each degree here on the y-axis as a 1 degree. So 1 is your x. It means after 1 hour, the temperature is 0 degrees. Now for the y-intercept, that would mean that after no hours have gone by, it is now going to be -5 degrees. So basically, when you put the thawed sample out to unthaw, it started out being -5 degrees. So that would be when x is 0, because when each intercept is listed, the other part of the coordinate is 0. So if you think of x equals 1, the ordered pair that goes with that is 1, 0. If you think of y equals -5 as the y-intercept, the ordered pair would be 0, -5. So we're basically describing the point. And like I said before, if it's x equals 1 and the ordered pair is 1, 0, that means after 1 hour, the temperature is 0 degrees. And back to the y-intercept, after no time has passed, that means -5 degrees. So basically when you start the process of thawing, it's -5 degrees. Now, the last part that we need to look at on this graph is whether there is symmetry. So think of splitting the graph down the middle, and if one side is looking the exact same as the other side, then it would be symmetrical. But in this case, since one side of our graph is starting down here, okay, and it's going up the entire time, if I were to split it in half, let's say with a big yellow imaginary line, and I would look on both sides, one side the line is way up here, the other side is the line is way down there. If we were to fold them on top of each other, they would not line up. So this is not showing any line symmetry. Okay? So it's linear because it's a straight line. We've talked about the x and y intercepts and what they mean. And the line symmetry, there is no line symmetry because when we split it down the middle, the lines will not line up. Now we're going to look at the same graph. I've taken away the labels, but I'm just looking at the numbers involved and the line involved here on the graph. So I'm going to describe when this graph is positive and when it's negative. Sometimes graphs can be all positive, sometimes graphs can be all negative, sometimes graphs can be positive and negative on the same line. So if we think about this for a second, when you're trying to think of positive and negative, you're going to be describing the x values is what they want. So you are going to take the x coordinates and look to see when it's positive and when it's negative. So on this graph, or on any graph, the right side of the graph, or the right side of the x-axis, is always going to be the positive numbers, and the left side is going to be the negative numbers. And it's split into two parts by the y-axis. So if we want to say when x is positive and when x is negative, we want to go to right here, right here, where x crosses the x-axis, and we want to say that when x is greater than 1, because the x-intercept is 1, so x is greater than 1, the graph will be positive. When x is less than 1, the graph will be negative. So this graph actually has positive and negative behavior. Here's the positive one, and here's the negative one. Okay? Now we'll look at whether the graph is said to be increasing or decreasing. Now, when you have increasing or decreasing, the graph has to be either increasing or decreasing. Sometimes it can increase, then decrease, then increase, then decrease. So in this case, this line that is drawn is consistently increasing, meaning from left to right, the line is going up. So that is what you are looking for when you're trying to determine whether it's increasing or decreasing. If one part of the graph is increasing and some parts of the graphs are decreasing, you would describe it like we did with the positive or negative parts of the graph. So you'd look to see when the x values are increasing, when they might be decreasing, and describe that using an inequality symbol, such as less than or greater than. But in this case, it's consistently increasing, so we would say that the graph is increasing. Now, whenever a graph is consistently increasing, you're never going to have what's called extrema. Extrema would be if you have bumps and curves in your graph, and you have an increasing section and a decreasing section, and you have a minimum and a maximum point on that line. So something like this, where you have a curve, then you would be considering extrema. But in this case, this graph does not have extrema. And when I mean extrema, I mean either a maximum or a minimum point. So in this case, there is no maximum point on the graph that we can pinpoint, and there is no minimum point because the graph continues to go to the right and up for an infinite amount of time. If there was a maximum or minimum point, you would look at the graph, and if you're going to look at this for me, this right here on my graph that I've just made here, this would be considered a maximum point on that particular hump of the line. Then you have something like this. This would be a minimum point. So when they are asking the relative minimum and the relative maximum of the graph, you would look for where it goes up and then back down. Or if it just goes up, then you just have a relative maximum. If it just goes down, you just have a relative minimum. So sometimes you don't have to have all of the behavior in the same graph. It could be just some of the behavior, like positive or negative, increasing or decreasing. But in this case, there is no relative extrema. Now the last part of the graph, it has us look at the end behavior. Okay, so if I were to go back here and look at my graph, that means when I get to the top of the graph, so right here, I need to determine what is going to continue to happen on my graph. Kind of like a prediction based on what the graph is doing at that point. So if we're talking about thawing out something, we don't really know what they're thawing out here, but thawing out something from the freezer, okay, we can continue to say that the longer it's let out, so the longer the sample is set out to thaw, the higher the temperature will be. And that would be describing the end behavior of that particular graph. And in any graph, you would look at the graph, you'd look where it ends on the very right side of the graph, and whatever the pattern of the graph is, and you make kind of a prediction based on what would continue to happen if the graph continued to look the same way. And that concludes Lesson 1-8 as well as Chapter 1. So, yay!